Okay, certainly a comparison test, limit comparison test. I'm gonna say limit comparison test has got an advantage. I don't have to solve an inequality. So I'm gonna say looking at it, a nice comparison for this one over here. The top's, like n squared. The bottom is, let me write this over here, n squared. The bottom is actually just n to the 5/2. All right, now looking at that, if I were to reduce that, I'm gonna say it looks like it's gonna compare nicely to this one over here. Because, 5/2 minus 2 is just a half. So I'm gonna use the limit comparison test. And let's write down, so it's limit as n goes to infinity, 3n squared plus n, and then on bottom you're going to get n5, the root of n5, I'm sorry. Let's see, plus 2n plus 1. And we're dividing by, 1 over the root of n, so I'm just going to put it as the root of n over 1. And I got to figure this limit out now. And to do that, it really doesn't look that bad. Now, a little bit of work maybe might help me. And I'm going to say 3, let's see, root n, and then that's going to be what? It's going to be n, that's going to be 5/2 plus n. Well, that's 2/2 and 1 3/2. And on bottom, what do you get? n5 plus 2n plus 1. I'm going to divide top and bottom by the highest degree variable, which is n to the 5/2. You're going to get 3 plus 1 over n. And then you're going to, over here, that's going to be, let's see, 1 plus, let's see, that's going to be 2 over, let's see, n4, and then plus 1 over n5. Well, this limit's pretty easy to do, actually. It's just 3 over 1. So the limit's 3. So what do I know? Well, this is divergent. This is a divergent p-series. And by using the limit comparison test, I'm getting a finite number over here, divergent, and we're done. Thank you.